Hello everyone! In this tutorial, we're going to look over the different types of variables in C++. We're going to start with integers. Integer is basically a data type that holds integers. Those can be positive or negative or a zero. So the way we will initialize it is basically type int and then the name of the variable. I'm going to name it num1. So here we have it. Num1 variable type integer. We also have floats. Float is a decimal number. It can hold decimal numbers. So I'm going to call this num2. This is going to be of type float, so the number will be stored as 23.0, for example, or 0.5 or 0.9 or whatever. Okay, and then we have double. Double also holds float numbers, basically decimal numbers, but the difference is that with doubles you have more accuracy. So this is 8 bytes while floats are 4 bytes. So it can store more digits basically. I'm going to call this num3, and I'm just going to write the number of bytes in each integer. In each data type. This is 4 bytes, and this is also 4 bytes, and here we have 8 bytes. Now each byte has 8 bits within it, so let's write it on top. 1 byte is equal to 8 bits, and a bit stores 1 digit basically. So 1 byte can store 8 digits. And so if we have 4, that's 4 multiplied 8. Okay. What else? We have char. Char stores characters. I'm going to call this char C. And this is 1 byte. So we can store 1 character in here. And we also have bool, which is short for boolean, and this stores either true or false. I'm going to call this B, and this is also 1 byte. Now we have also some variations of the data type integer. We can say short, for example. Short is an integer data type, but it has 2 bytes instead of 4. So if I said short num4, this has 2 bytes, and we can say long num5, and this has 8 bytes. So basically for integers we can store them in integer, which has 4 bytes, or if we need less bytes so as to not waste space, we can use short, or we can use long if we need bigger integers. Okay, now if we don't know the size of a data type and if we want to figure that out, we can basically use sizeof function. This is a built-in function. We can say size of and then the name of the variable. So I'm going to type num5, for example, and I'm going to print it out. Let's check. Okay, so basically it says here 8. So num5, which is a long data type, it's 8 bytes. We can try all different ones. Num1, for example, that's integer, it will be 4 bytes, and so on. Let's try the char. Okay, this is 1 byte, and the boolean is also 1 byte. Okay, 1 as we can see. So right now I'm going to give these values, and let's say this is equal to 2, this is equal to 9, and then we're going to play around with these variables later. Okay. And for char, I'm gonna open single quotes and write D, for example. That's a character. And with booleans, you can either store true or false. So I'm gonna say true, just like that. Now, booleans, they don't actually, you don't store the word true in the memory. What gets stored is either 0 or 1. So basically 0 means false and 1 means true. So I can say 1 and it will still be considered as true. Okay. So you might wonder, how large of a number can we store in this int variable? I mean, 4 bytes, we know that each byte is 8 bits. Okay, so in total, 4 multiplied 8 is equal to 32. 1 bit can either be 0 or 1. In computers, we can only store 0 or 1 in the memory. So that's in binary numbers, of course, and it gets converted to digital or decimal numbers. So basically, we can store, if we have 4 multiplied 8, that's 32. 1 bit of those 32 bits is reserved for the sign, whether it's a positive or a negative sign. It's also stored as 0 and 1s. And so depending on the compiler, 0 would be 0 would indicate a negative, for example, and positive might indicate 1 or vice versa. But we know that 1 bit is stored for the sign, and so we have 31 left bits to play with. So we can calculate the number. If we said 2 to the power of 31 is equal to 2 billion and whatever number is here. So this is the largest number that we can store in the integer data type, whether this is positive or negative. So positive 2 billion blah blah blah, or negative 2 billion. Now if we don't want to use this extra 1 bit for the sign, we can get rid of it and use alt32. We can leverage alt32 bits to store numbers in it. How can we do that? We can just say unsigned integer. So if we have an unsigned integer data type, now we can change this to 2 to the power of 32. Now we get 4 billion and something. So we can basically double the number that we can store by typing unsigned number if we don't need the signed bit. So this will only store positive values. So keep that in mind. One more thing that we need to know about the char data type. This is actually stored as a number in the memory. Every letter has a number associated with it. So I believe D, for example, would be, let's try 69, if I remember correctly. Let's check it out. If I print it out, the C variable is going to print out the D variable, or whatever number that is associated with the number 69. So let's try this out. Okay, it's E, not D, so I missed that, but as we can see here, 69 is associated with the letter E, and in the memory it is stored as a number. So we can do it this way as well. Obviously we don't need to, but we just need to know how the program works. So 64. Okay, this is the @char. So as we can see, the punctuation marks, the letters, all these kind of stuff are stored as numbers because memory doesn't store any other types. They don't store letters or punctuations or commas or anything like that. If I did 65, that would be the letter A, for example, and so on. Okay. Now we can change this back to E, for example. Cool. So that's all we have for the data types. These are the primitive data types. Now, obviously, we can create other data types, custom data types, but we base them off these primitive data types. So we can basically store any data kind that we want. And also these variables can be converted to pointers or references. If you want to convert this to a pointer, we can put an asterisk next to it. And if we want to convert it to a reference, we can put the and sign next to it. But these are huge and complicated topics, so I'll save them for another video. And thank you so much for watching. See you in the next one.